Welcome back to another class with me, Ming. Today we look at sigma notations. Here are the learning targets. We will first consider this series. This series is 1 plus 2 plus 4 plus 8 and so on. And the idea is that can I write this in a shorter form? Well, yes, the answer is yes. And I can re-express this as 2 to the power of 0 plus 2 to the power of 1 plus 2 squared and so on. Right? And you will see that the general term here, the general term is just 2 to the power of r, where r here is a number between 0 and 5, and r is an integer. So with this idea, then I can rewrite S6 as this is a sigma, it's a Greek alphabet for S, and we put the general term inside 2r, and we say that r here starts from 0, ends at 5. So this is exactly the same as that. So every time you see this, it means that you start with I equal to 0, so put in 2 to the power of 0, next 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. That's the end. So this, and sigma here means sum, right? Summation here is adding. Next, we look at this example here, S4. Oh, by the way, this, I hope that you recognize this is actually a geometric series. Right, this is a geometric series. Over here, I have a 1 over 3. So let's write it out. 1 over 3 to the power of 1 plus 1 over 3 square plus 1 over 3 cube plus 1 over 3 to the power of 4. This is the general term in this case. Is 1 over 3 to the power of r, where r here is a number between 1 and 4. So in terms of sigma notation, this is written as sigma 1 over 3 to the power of r. R here starts from 1 and ends at 4. In fact, again, you can see that this is again a geometric series. Now, this is what we call the count for the summation, right? And the count here doesn't always have to start from, doesn't always have to be r. Sometimes you see it written as I, from 1 to 3, for example, 2 to the power of I, for example. It can also be written sometimes using j. J 0 to 4, for example, 2 plus j, for example, could be another example. Sometimes it can also be using k, for example, just k. K here goes from 2 to 6, for example. 2 to 6, for example. Now, the starting here can be any number that you want, and the ending here also can be another number, any number you want. Usually, the ending is larger than the starting point. You should be able to recognize that a sigma notation of this particular form, for example, I equal to 1 to m for a to the power of m, where a is any real number, right? And m here is a positive integer, for example. And for convenience, we let m to be larger or equal to 2. So it's m is an integer larger or equal to 2. This particular form is actually a form of geometric series, where the common ratio is equal to a, and the first term in this case is a to the power of 1. Right. So next time when you see this particular notation, you should recognize it as a geometric series.